Alright, one is August 18th. Alright, let's do this. This is for August 18th. We have about an hour before it closes out for today. An ugly number is a positive integer whose prime factors are limited to 2, 3, and 5. Given an integer n, return the nth ugly number. An ugly number is a number whose prime factors are limited to 2, 3, and 5. So it's an or. It doesn't have to be. It's like as long as it only contains 2, 3, and 5, it was good. And we want to know the nth ugly number. The 1 counts. 1 has no prime factors, therefore all its prime factors are limited to 2, 3, and 5. So basically 1 is 2, 3, 4. 4 is 5, 6, 8, 9, 10, 12. So we go all the way to 1690, right? 1690. And what we need to make sure is there's no prime factor of 7, right? 7. 2, 3, 5, next one is 7, 11, 7, 11, 13, 17, 19. So we can keep going until we hit, 1690. What is 1690? Or we can go through them, just find all the, that's probably not gonna work. Or we give a number and we, because it has to be, so if we can go one by one and just to check, right? How long is that gonna take? Well, I guess it will work. I mean, it's not that much. N is only 1690. $16.90. So that all the 7 or multiple of 7 will be gone. All the 9s, multiple of 9s. All of those will be gone. And eventually when they go count, right? Yeah, this is a good question. How long is that going to take? And how many? Because n is 1690. That doesn't mean we'll only extend to 1690. Or I can ask, what's the 1690th ugly number? That is to ask the first 1690 number that does not have any prime factor of 7. So we can get 7, right? We can get, if it's going to be a sieve, I'm thinking about a sieve, right? If it's going to be a sieve, we get rid of them, we get rid of all the 7s or the 9s. I mean, how much you going to go for, right? How much you going to go for? Well, I think if we, prime numbers, right? The biggest prime number that's smaller than 1690, what is that? That's how many we have to go through. That is how many we have to go through. And we can check, I guess. But like, what's the ultimate range? feel like we can brute force this. Sieve wise, yeah, I don't know. Sieve wise, what do we need to do for the if we want to go with a sieve method? I don't know the upper bound. That's the thing. We don't know the upper bound. 1690. I don't know. All right. How about we brute force it first, and then we see if it works. If we brute force this. If we brute force this, how would you brute force it? We'll have a function called isUgly, right? We call private, call it boolean isUgly, and then we just say if it's ugly or not, and then we're just gonna do the prime factor of it, right? And then we can say set integer allowed new set hash set allowed hash set. I think I can do this 2 3 5, right? Ooh, how do I initialize or I actually don't know. How do I initialize a set? Java initialize hash set. I honestly have no idea. Arrays dot as list. Okay. So we can call it. Okay, we'll call it arrays dot as list. 2 3 5. Okay. So basically, we're gonna do this and n2, but all right. But if you want to do that, what's your list of prime numbers? Good question. What's your list of prime numbers? What is your list of prime numbers? Well, we just don't consider the list of prime numbers. We just go one by one, all right? We get rid of 2 first, and then we get rid of 3, 4, 5, all the way until, until half, not half, like sqrt, as value, right? And then we can say so we say get rid of 2, get rid of 2's, while n divided by 2 is equal to 0, right? And then we say n divided equal to 2. Okay, so get rid of all the 2's, and then we say p start from 3, right? Say while n, I don't know, larger than 0. If n mod p is equal to 0, n divided equal to p. Okay, if not, then else n divided equal to p. Else, if it's not if it cannot be removed anymore. What the hell? Else p plus equal to 2, right? And larger than and n times p times p is smaller or equal to n. Okay, we also need more things here. So P is a prime factor, right? And then if it's a prime factor, if allowed, right, dot contains P. If it does not contain P, then we should return false, right? Otherwise, we should keep going until we get out. Now we get out, we shall say if n is n should equal to 1, right? Because it's only if it's good, I divide equal, and we keep going. If else, P will just plus equal to 2, plus equal to 2, plus equal to 2. All the way we'll go there and then reach the level n. I reach the level, so n if it's not equal to 1. Yeah, should be this or should be larger than 1, right? We should return if n is equal to 1. Right, ugly means, yeah, if it's ugly, right? If it's ugly, only 2, 3, 5. Okay, so that's that. And then we say, not rest, it should be count. If n is equal to 1, return 1, right? Otherwise, count already is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? And then, just say, while count val 2. Count is smaller than n. If is ugly, val is ugly. Yep. Count plus plus. And m now and val plus plus. Is that right? So start value is 2. Then if it's ugly, count plus plus. Now we'll go for 3. And keep going, keep going, keep going. And in this case, I don't even need this. I can just say count as 0, start with 1. Count is smaller than this. Yes, it's ugly. Well, 1 is ugly is true because it's true. Count plus plus. Get out. Now I return val. Yeah, this is brute force. Not sure if it's gonna work, but oh, yep, it's not working. TLE, but at least it's gonna be correct, but it's gonna TLE. Yeah, there gotta be an easier method than this. Wait, hold on a second. I think we have other issues. We probably have other issues here. If we cannot even do 100, can we even do 1, 2, 3, 4? 1, 2, 3, 4 is not even right. Alright, we have other issues. 1 is not counted. What? N equal to 1 is ugly 1. 1 comes in. 1 is false. Right? Doesn't do. So it's true. Right? So 1 is ugly. 1 is ugly. So if it's ugly, count become 1. And oh, val plus plus. Dang it. Alright, val we plus plus at the first, at the beginning. Okay, 1, 2, 4, 8. 1, 2, 3. What happened to 3? What happened to 3? Three. Interesting. 3 is not right. 3 comes in. Count is 0. Smaller value become 1. 1 is ugly, so count become 2. No, count is 0. Count is 1. It's currently a 1 count, right? And now count the val become 2. Check 2. 2 is correct because n become 1. So 2 is true. Okay, now 3. Val is 3, right? So we check 3. 3, this is so we're gonna get p is 3. 3 larger than 1. P. Oh. Huh. P is 3. N equal to 1 or we can just say this. Yep. Now 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, now it's correct. But if we 100, probably will time out. Because I have to go through every single one. Okay, 1000. We did have some error earlier. Yep, 1000 will time out. So yeah, still this is not the right way. I don't know. There's some way you can make it faster, like make it jump. Or if I know the previous one, can we predict the next one? Because there's only 2, 3, and 5, so either times 2, or something times 3, or something times 5, right? So 1, 2. Next one, so either 1 times 2 times 3 or times 5 will be 2, right? Then you go back, you can say 1 times 3 times 5, 2 times 2 Yeah, it has to be 3. Next, it's every time you have to go from the front. Right, you have 2, 3, 5. Right, currently the 2, 3, 5. So this will be smallest 5. The smallest is going to be 4. That hasn't used. Yeah, it's just everything times 2 times 3 times 5. And we just see which one has not been used yet. That's a different idea. Maybe we can do, I don't know. 1 is the first, right? And then we just times 2 times 3 times 5. I put in a priority queue. Pop the first 2. Every time I do, we times 3. Pop times. Oh, that actually sounds like a better idea. That's actually a much better idea. Okay, let's do this one. We'll use priority queue. All right. So priority queue, and we're gonna have not the list, but a count. We're still in the count, and the priority queue of integers. Shouldn't just be integer dot compare. Wait, I think it's AB integer dot compare A B. Okay, so I have priority queue, and there's a queue dot add 1. All right, and then what we're gonna say is while n. Okay, while n, pop out is the current, interest, while n is larger than 0, rest equal to q dot poll okay, and then q dot add rest times 2, q dot add rest times 3, q dot add rest times 5. Or I can just, we don't need this, we can say int allowed 2, 3, 5 for int a of allowed we say q dot add rest times allowed. This is allowed, right? And then not allowed times a, right? And then n minus minus. Okay, and then whenever n, we just return rest. Let's see. This seems to be a kind of a different idea. I'll say completely different idea. Let's see if this one works. That is not correct. It's definitely fast enough, but it's not correct. Why? Why is this not correct? Oh, because you can multiply. Yeah, that's all right. Because it's. Wait, hold a second. Why is it not correct? Let's do 1, 2, 3, 4, 5, 6, 7, 8. Maybe 1, 2, 3, 4, 4. Let's kind of get an idea where we're at. Yeah, the beginning is correct. And everyone got to multiply it by at least once. Interesting. 10. 10 is not right. Output is 10. So we are kind of getting something wrong here. So 1 get to 2, 3, 5. Alright, and 2 pop out. 2 can give me 4, 6, 4, 6, and 10. 3 will get me. Oh, I see. There's duplicates. Allowed set integer scene new hash set. So we pop it out and we say scene.add 1. Okay. If scene dot contains res times a. If it does not contain, then we add it. And scene dot add res times a. Otherwise, we don't add it. Okay, with this. I'll have to wait. Okay. Yep. I think that is the solution. Oh dear Lord. Thank goodness you checked. Becoming more and more, you know, so it has to be long. Alright. Okay, so result is gonna be an int. Yeah. But what might happen is along the way it may be a long. So this is gonna be a long. That's fine. Rest is fine. Rest is a long, and scene is a long. Priority queue is gonna be a long as well. All right, let's rest queue.poll cannot convert long to int. Alright, so this is going to be a long. Everybody's long, and then we just convert into int at the end. That has to be long. Okay, so yeah, we can actually do the instructions here. We say, that's an interesting question. That's actually very interesting. 264. I tried brute force, where each integer is checked for its ugliness. It times out, of course. And then another idea occurred to me, that all the ugly numbers must be the result of some previous ugly number multiplied by 2, 3, or 5. Thus, we can use a priority queue to keep track of the smallest ugly number so far, right? Ugly number so far. And from there, we can produce new ugly numbers. This is distracting. We have to pay attention to two things. First, duplicates. Second, integer overflow. I don't know the runtime for this. Call it O n log n, but it's not really O n log n. O n log. I mean, it is O n log n. It is O n log n. Yeah, it is O n log n. Because each time you add 3 values to it, so it is O n log n.
Mm-hmm.
Yep, that's what we are looking for. Oh, I've done this before. It's an old problem. Let's see how we did last time. 2020, 4 years ago. Man, 4 years seems to be such a long time. What the hell are you talking about? Bisect right, scene current divided by factor. Lower bound of the potential number for making the next ugly number. So factor, current, and scene list. Welcome to Redmond, Seattle. What the hell? Wow, it just happened like that. Huh. Alright, I don't quite understand my previous solution here. I think what I'm trying to do is, given the current value, right, and I say I'll divide it by 2, 3, and 5 and find the most likely, basically the smallest, right, the smallest that can be made, because we use binary search to find the previous. Oh yeah, this is the same thing. It's just to think about it from a different perspective. This is to think about how to make the next one by consider the current one, and I'll divide by all of them, and to find the factor, to find something in the ugly, right? Find something in the ugly that is closest, right? That is closest. Ah. Yeah, and then we do. Oh yeah, it'll work. But it feels it's easier to do it this way, at least to me, right? We are using priority queue. Space complexity is worse because I need to check for duplication. I wonder if there's a better way. Using a set. Ah, it's doing that. It's the same idea, right? It's just directly a set. But this you need to have a scene, yeah. DP can achieve ON. That is interesting. How do you get to ON from DP? Yes. Really? Yes, this is correct. So just move, so from 1, we produce 2, 3, and 5. And then what? And then okay, this is not. Ugly number is equal to next ugly number of 2. The next ugly number will be 2. Since the next ugly number is equal to the previous, update index multiple of 2. Next multiple of 2. So basically we have 3 indices, right? Index for multiply of 2, for multiply of 3, and a multiply of 5. Okay, I have 3. And then we initially, right, we have 1, 1, 1, each one is 1. And then we do this and find out that the smallest goes to 1. 1 times 2. So that need to increment to the current smallest. So the multiple will be 2, right? So the multiple will be 2, 1, 1. Next round we do it again, then 3 wins out. So next time 3 will become the smallest. So 3 will become 2, right? And then next one will be 4. I think I know what this one is trying to do. Let's try this. Think I know. Okay, this is the official solution using DP. We will use 3 pointers for multiples of 2, 3, and 5, right? And the smallest, and the pointer that produces the smallest current ugly number gets to increment to the next, right, to the next. This guarantees that all ugly numbers are produced by previous ugly numbers multiplied by 2, 3, or 5. And since each time we are selecting the min, the produced values are always in order and unique. So we do need to have a scene. Right, we need to have a scene because we need to increment the pointers. Okay. So we have a list of integer. Uglies. I'll put 1 in there. Man, if n is equal to 1, we just return 1. Easy, simple. Alright, we'll get this case. Otherwise, we do that. And then we can say pointer p2, 0, p3, 0, p5. Okay. Then, while uglies dot size is smaller than n. Okay, so we can say the 3 things. How do I I don't like this. Pointers int pointers new int 0, 0, 0. Okay. So we are going to, so this is pointers and vowels. Okay, so this is pointers and values. So each time start, we'll go through this and then find the next one, right? Or find the next one. Actually, we don't even need this because we're going to return uglies dot get uglies dot size minus 1. Okay. So val, so for int p of pointers. That's not right. I smaller than 3, I plus. Okay. Then we can say vals I shall equal to uglies dot get pointers I multiplied by, holy crap, so have pointers factors 2, 3, 5, right, times factors I. Okay, and then we will find the smallest. All right, we're going to find the pointer that is the smallest. So we say int main val. I don't know. Main val is going to be integer dot max value. Int index, mean index. Doesn't matter which one. Okay. I say for int I 0 I smaller than 3 I plus plus. If vals I is smaller than main val, then main val is equal to vals I and mean index is equal to I. Alright, we'll go through this. Now we get the mean val and we get the mean index. And next thing we do is we'll say uglies.add mean val, then pointers mean index plus plus. And now we do this until we're ending. All right, let's give this a shot. Of course, this is wrong. That is not right. All right, let's see. Where did we get it wrong? That's a 10. Oh, what happened? Duplicates. Duplicates happened. How to check for duplicates? Well, when you get out, it has to be the smallest, and because this is a big, it's definitely not going to be in there, right? It has to be the smallest that has not occurred in it, right? The smallest that has not occurred inside what we have already. How do we handle this? Do we need to have us use a scene? I don't see. I don't see it. I mean, it's the same idea, right? But so we get a next ugly number, which is the mean value, right? So if it's the same, then we always so what we're saying is if there happens to be, so we did get a mean value, but we're not incrementing, right? If you oh yeah, okay, I see. So we get a mean value, right? So you get 3, we get a mean value out of them. And okay, I see. So we don't do this. Then I don't even need to keep track of them, right? I do, because I need to know what they are in the moment. Okay, so we get the 3 values, and we need to get the mean at the same time. Okay, let's do this. So So we'll get the min at the same time. So val is this, and then we say min val equal to math.minimum vals I and min. Okay. Once we're done, if vals is equal to min val, then pointers I plus plus. Then we do this, then we do this. There we go. This is a crucial, okay, crucial step. We need to update the pointers, right? Update a pointer, update any pointer that can achieve, right, the same min val at the current step. Any pointer, right? Then that means this is to avoid duplicates. All right, because we have a min value at the current step. Right, because everything is keeping us low. Right, and then we say this into multiply by 3, multiply by 5, and then if they become the same, I mean, it's already done. Right, so we cannot, yeah, this is to avoid. This is to avoid duplicates. Okay. Let's see, 1690. Yeah. Faster. Much faster. All right. That was good. I'll see you guys in a couple minutes.